Hi all, here are a couple examples. Two examples will be on two sample t-tests, and then one example will be on the paired t-test. So in this first example, we have a high school guidance counselor is wanting to know if ninth graders have more free time than 12th graders in his school. So he has two samples. He has 25 ninth graders and 23 12th graders, and each student was asked to report how much free time he or she has in a typical week. So the mean for the ninth graders is 29 hours with a standard deviation of 7 hours, and the mean of the 12th graders was 22 hours with a standard deviation of 6.2. And again, we want to determine whether ninth graders have more free time than 12th graders. Okay, so first of all, let's notice in this problem we are comparing two means, and it's not a paired t-test because we have two independent samples. Therefore, it's going to be an independent two-sample t-test. So let's label what the two groups are first. So in this example, we have sample 1 is going to be, let's put it as ninth graders, and our sample 2 will be the 12th graders. Okay, so going over to StatCrunch, we go to Stat, T-Stat, two sample t-test with summary. For our first sample, that's the ninth graders, our sample mean was 29 with a standard deviation, sample standard deviation of 7. Our sample size was 25. And for sample 2, that's the 12th graders, our sample mean was 22, sample standard deviation was 6.2, and our sample size was 23. And remember here, we never want to pool the variances, so uncheck this always uncheck this. Okay, so the hypothesis was that the ninth graders had more free time than 12th graders. So we want to know if sample 1 is greater than sample 2. So we have greater than. And this, remember, in the slide it said if you add mu2 over to this side, that means greater. Mu1, sample 1, the mean of sample 1 will be greater than mu2. And that's what we want. So we hit compute. Hit compute. And now we're given our results. So we copy this. And we go over to the document. Paste it. And again, we're always given our hypotheses and our test statistic and then our p-value. So our conclusion is reject, let me scroll down, reject H naught if the p-value was less than 0.05, which was our alpha. And in this case, our p-value is 0.0003, so yes, we reject H naught. There is sufficient evidence to conclude that ninth graders have more free time on average than 12th graders. And that's it. So going on to our second example, an entomologist has 12 plots of land. 6 are treated with pesticide and the other 6 are a control group. And at the end of a 2-month period, the number of potato bugs on each plot will be counted. And here's the data. I put it into a table, and we want to test whether the plots that were treated with pesticide have fewer bugs than the control group. So we will call the control group sample 1. So sample 1 is the control group. Sample 2 is pesticide. That's the treated group. So going over to StatCrunch again. Actually, we need to copy the data first. Just copy the values and not the variable or the control and pesticide, because if we, so exit out that, if we can Control C, Control V, we can name the column heads. So that's control, remember, and then this is pesticide. But we can't paste, we couldn't paste the control and pesticide there. So now we go to stat, then again tstat, to sample, and with data this time. So we select the column for sample 1, we said that's the control. Sample 2, we said that's pesticide. And again, uncheck pool variance. Our hypothesis in this case, we want to know whether the pesticide group had fewer bugs than the control group. So we want to know if sample 1 is greater than sample 2. So that's the same as greater than. So we hit compute, and we get our results. So we copy this, put it in, paste it, and so these are the results. So we see we get the hypotheses, and we have our p-value and our test statistic. Let's scroll up. Okay, so our conclusions always reject H naught if p-value, and in this case our alpha level was 0.05, so less than 0.05. And we see that our p-value is greater than 0.05, it's 0.0726, so we fail to reject H naught. There is insufficient evidence to conclude that the pesticide plots have fewer potato bugs on average than the untreated plots. And that's it for the second problem. For the last example, a company sent 6 of its salespeople to attend a course on how to be a successful salesperson. The table gives the 1-week sales of the salespeople before and after they attended the course. And so we want to know if the mean weekly sales for all salespeople increase or due to the result of attending this course. So let's first notice this is a paired sample because we have the same salespeople before and after. For example, George's number of sales before is 12, and after his number of sales is 18. So let's copy and paste this data again, just the values. So we go to StatCrunch, fix it out of here, and I'm just gonna paste this right here. You can keep this, it won't affect your data. So this was before and after. You don't have to label these, but it's easier when to distinguish what columns are what. So I go to stat again, and I go to t-test, but this time I want paired. And our point is we want to see if the sales increased after the course they took. So we're going to put sample 1 as after and sample 2 as before. So if indeed it did increase, the sales increased after the course, this will be a positive number. You can do the opposite, and if it increased, it would just be a negative number. But okay, so I'm just going to click differences to show you what it does. And then our hypothesis that it's increased, so the difference would be greater. So greater than, and we hit compute. So that's our results. So we copy this, go over to our document, paste it, and as always, we reject H naught if p-value is less than 0.01. And for this case, our p-value is less than 0.01. So we reject H naught and conclude there is sufficient evidence to conclude that sales increased after the course. And that's it.